Hey everybody, welcome back. Over the last few videos, we've talked about linear transformations of variables and how those affect the mean and the variance, and then linear combinations of random variables and how those affect the mean. And now we can finally talk about the variance as well in this video. Essentially, what we want to do is think of a whole bunch of random variables, like let's say stock prices. And we might want to construct a portfolio that's a weighted average of a bunch of those individual stocks. Now, our overall portfolio will have a variance as well. It's going to go up and down. But we'd like to know how much it goes up and down and how those fluctuations in our portfolio depend on the variances and covariances of all of those individual components. So more broadly speaking, what we want to know is the variance of a weighted average of random variables. So let's dive right in. So let's say we've got some random variable. Let's call it z. And z is itself a weighted average of two other random variables, x and y. Let's say it's 30% x and 70% y. Or more broadly, it could be some random percent x, a, and a random percent b of y. So a% x, b% y. And we'd like to know what is the variance of z. Now, ideally, we would know what the variance of x is, the variance of y, and really importantly, how x and y vary with each other. And if we know these things, the variance of x, y, and the covariance of x and y, then we can figure out what the variance of z is. Now the punchline is this right here, that the variance of z, which is itself ax plus by, this thing is z, the variance of that is a squared the variance of x, b squared the variance of y, plus ab times the covariance between them. Now you can take my word for it, or you can listen along and I'll show you why this is the case. And then even if you don't think you need to know the why, I'll show you a very nice little trick on how to get the variance of even more than just two random variables. It turns out there's an easy trick to figuring all of this stuff out. But that's going to come in the second half of this video. First, I want to just show you, like, where does this formula come from? So like all of our work so far, we start off with a definition. Right? The variance of any variable, z, is equal to, well, let's take one particular observation, subtract off its mean. So how far away is the observation from its mean? Square it. Then we want to do that for all of these observations, all n of them, not just the first one. And then divide by n so that we get some kind of an average. Now z is ax plus by, so the variance of z is going to be 1 over n. Now we need to do a zi here, so it's going to be axi plus byi minus the average of z. So that's just ax bar plus by bar. Okay, and this of course needs to be squared, so we put in a squared term right there. Now notice that a kind of shows up in two places and b shows up in two places as well. So let's put those a's and b's together, and we get axi plus ax bar plus byi plus b. Oops, I have a typo here. This should be a y, not a y. So it's by bar, and then we're squaring. Let's pull out those a's from here because it's a common factor. So we have a xi minus x bar, and then we can pull out the b from here. And that whole thing is squared. Okay, so now it's time for us to square. Now, this is just foiling, right? You're going to take, this squared plus 2ab. So let's do that. We get a squared xi minus x bar squared. So that's this first term squared. Then we're going to square the second term. And then it's 2 the first times the second. So a, b, xi minus x bar, yi minus y bar. Okay. And we don't need to put the squared term anymore because we just FOILed this thing. So we got rid of that squared term. The next thing we can do is split up this summation, because it's a sum of 3 sums, and you can just reorder any summations like that. And so we would get 1 over n, the first summation, so that's a squared xi minus x bar squared, and then the second summation, and the third summation. Okay, our next step is going to be to take out these guys and put them outside of the summation sign. The reason you can do this is because this is a constant. Here, this thing varies for each term, as I changes from 1 to n. These guys change, but the a, that's just a constant. It shows up whether I is 1 or I is 2 or I is 3. So it's just a common factor that we can pull out. And that gives us a squared. 1 over n xi minus x bar squared. Do the same thing here for the b squared. And then here, a and b are constants, so 2ab is also a constant. You can pull that out. Okay. Now we should notice a couple of familiar terms. As a reminder, the variance of a variable is observation minus the mean, square it, and divide by n. So this is the variance of x. And by the same token, this is the variance of y. And then this is the covariance between x and y. So plus 2ab, the covariance between x and y. And so there we go. We have now proven what we needed to prove. QED, as they say. So I promised you a shortcut, and here it is. Let's say that you wanted to know what the variance was for a particular variable. And let's say this one was weird. This one was 3 terms. It was ax plus by plus cw. Then the covariance, the variance of z is going to be pretty gnarly. But the trick is it's going to consist of a bunch of covariances. A whole bunch of these things. In fact, what we're going to do is take every single one of these terms, these 3 terms, and mix and match them every conceivable way. So we have ax, let's make a little table, by, and cw. And here we have ax, by, and cw. Okay, so what are all the combinations of these? Well, we have 3 terms, so we should have 9 different combinations. We could have ax and by, we could have ax and cw, or we could have ax and ax. Likewise, all the things that can match up with by. AX, BY, 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 and BY, CW. And then all the things that can match up with CW. So AX, CW, BY, CW, and CW, CW. So we have 9 different covariances. And that's ultimately what this thing is. Our final answer for what the formula is for the variance of Z is really the covariance of each of these things added up together. So in other words, the variance of Z is, I'm going to write this out, this will be lengthy, but it's the covariance of AX and AX plus the covariance, now of this one, so it's AX BY plus the covariance of AX CW plus these 3 covariances, and then these 3 covariances. So I'm going to write these down real quick. Okay, the next thing for us to remember is that the covariance of a variable with itself is just the variance of that variable. So when we see covariance of AX with AX, that's just the variance of AX. All right, so that was this guy here. Here we've got the variance of BY. Here we've got the variance of CW. Okay, so we've got all of our variance terms. Now we still have those odd covariances, the ones we couldn't get rid of. Okay, so here we have AX and BY. Let me see here. AX and BY. But hey, look at this. That shows up here. There's 2 of those. So we have plus 2 times the covariance of AX BY. And what about AX CW? Well, we have 2 of those too. So plus 2, the covariance of AX CW. And then we've got this BY CW, 2 of those. Okay, we're just one step away. Now we just need to pull out all of our constants. So you'll remember from a previous video that the variance of AX is A squared, the variance of X. If you don't remember that, there should be a link somewhere up on top. Be sure to click on that. We got to pull out this B. So we have B squared, the variance of Y. C squared, the variance of W. And then we've got all these terms here. So we have 2AB, the covariance between X and Y, plus 2AC, the covariance between X and W, and 2BC, the covariance between Y and W. And so that is our final answer. So really all we're doing is we're taking every single variable and trying to pair them up, even with themselves. Every possible pairing of all of our weighted average terms. And then we just apply our old familiar rules for linear transformations, the effect of a linear transformation on a variable. That rule right there. Okay, so you are now equipped to figure out on your own what the variance formula would be for any number of added weighted average terms. So if your professor pulls a fast one and says, well, what would the weighted average for z be, or the variance of z be, if it's a weighted average of x, y, w, and m, then you can just apply this rule. You would have 4 terms, so you would have 16. 4 times 4, 16 terms in this table, and so you would have to simplify a whole bunch of terms, but you can figure that out. So it's not that bad. Anyway, thanks for listening, and I'll see you next time. Bye-bye.